Welcome to Zero Shot Espresso, the show for AI engineers who are tired of building data pipelines. In this podcast, we talk to engineers and founders about deep systems engineering and the messy reality of data in the age of AI. My name is Jay, your host for the show. I'm co-founder of Daft, and we are building data systems to power AI products. Today, I'm excited to have Frank Liu with me. A quick introduction to Frank. You've really built a career around search. And I think with AI now in the mix, it's becoming super important. First Yahoo, then kind of your own startup as CTO, and then at Zillis, at VectorDB, and now with Voyage and into MongoDB. You've always been in this kind of database search space. Yeah, maybe for folks in the audience, why don't you tell us a little bit about your journey so far?
Yeah, I would love to. First off, thanks for having me on this podcast. I think it's great to be here. Really, I would say my journey starts at Yahoo, and that was the very first time that I really got a chance to dive deeper into neural networks. Back then, it was the Wild West of deep learning. This is like 2013, 2014, 2015. Nobody really knew what they were doing. But one of the things that I found really interesting was that there were papers papers very early on about this, where if you took the penultimate layer of a neural network, a trained neural network, just using categorical cross entropy, and you use that to do, you train, let's say, a classifier based on top of that, or you tried to do some nearest neighbor search based off of that, you would get some really interesting results. So you could take an image of, let's say, a mountain, search for nearest neighbors, and you would get pictures that correspond to other mountains, right? And I think that was my first exposure to embedding-based search and retrieval. And I've sort of continued to be in this space moving forward. The startup that I did, we actually built a lot of small neural networks. And although it wasn't extremely focused on embeddings, we were more focused on the application side. We were building indoor localization using these neural networks. It was still, being in and around ML, I think was still really important. And taking me to where I am today, I got a chance to work a little bit, see a little bit of the data infrastructure side of things at Zillis. They're the creators of Milvus, which is one of the world's most popular vector databases. And then finally with Voyage and MongoDB as well. So just for a little bit of context, Voyage AI is a company that does embedding models and re-rankers. And Voyage was acquired by MongoDB actually earlier this year. So now I am at MongoDB. I continue to do a lot of search and retrieval, and quite frankly, a lot of the stuff I think that we do really goes all the way back 10 years ago to some of the things I learned over at Yahoo. So it's certainly been a wild ride. It has been very fun seeing the space of information retrieval just ebb and flow and just morph into what it is today. Now everyone's talking about context engineering, and everyone's talking about agent memory and all this kind of stuff. And it's been absolutely wild.
Yeah, I feel like it's really come into the fore as the LLMs gotten more and more intelligent, right? Because you can have a super intelligent LLM, but if you don't give it the right data and the right context, then it can't do its work. And so I'm super interested to talk a little bit more with you today on this podcast about that. Yeah, one thing I keep coming back to is that it feels like one of the next frontiers of LLMs and unlocking what agents can do for us is really giving it good search and retrieval. And from the very beginning, we had RAG, right? This big wave of RAG stuff. And then, I don't know, that term kind of died out a little bit. And then now it's all about context engineering, but it feels like it's all the same thing. I've really just started to think of LLMs as like unstructured query engines. So you have SQL, SQL for querying tables and structured data, but LLMs are kind of the same, right? You pass it a natural language query and expect it to give you back a natural language answer. But in order to do that, you have to feed it with all the data. And, from all the buzzwords, I'm really curious to get your thoughts. How has search evolved throughout your career? And now with the AI stuff, how have you seen maybe the last 3 years of search within AI? And what does that look like over the last 3 years? And give, folks in the audience an idea of the evolution so far.
Oh, yeah, absolutely. That's a great question. I think I'll actually make an analogy about this first. Now I'll take a step out. I'll explain why I think search is so important for AI. So when I have some spare time, I'll play a little bit of chess, and I'm not that good, by the way. So, for anybody listening, don't, it's not like I'm a grandmaster or anything like that. I'm very, I'm very much a beginner, but a lot of, these days there are these chess engines that are really powerful, and they will beat, the absolute top grandmasters in the world, Max Carlsen, Fabiano Caruana, and there's sort of, I think, I want to say, two styles of chess engine. One combines neural networks with search, and another one is just saying, hey, let's throw as much reinforcement learning at the problem as possible, and let's actually not do that much search. So on the former, there's, like Stockfish, I think, is the most well known one, and the latter, I think the Chess Zero is probably the most well known one there. And if you look at chess engines that actually combine search with AI, they tend to do better. They tend to Stockfish, I think, for there are these sort of chess engine championships. And Stockfish, I think, has actually generally performed much better than Leela Chess Zero over the past couple of years. Even though there was at one point Leela Chess Zero was pretty dominant.
Yeah,
And
and
I
give
think it's
folks like between these two engines, what's like the main differences between the two?
great question. So Leela Chess Zero tends to just say, "Hey, let's throw a neural network and let's throw reinforcement learning at the problem as much as we can," and there's less search involved. Whereas with Stockfish, my understanding is that the neural net is a little bit lighter weight, and they put a good amount of emphasis on search as well. So there's I don't know a lot of the details, but they'll actually they'll say, like, there's a search depth, and they'll use a neural network, a smaller neural network, to prune some of the nodes or some of the paths that don't really make sense, or that don't lead to good positions for the engine. There's sort of like two camps here, right? One is to say, hey, let's combine search with AI, and the other one is to say, let's try to make the AI alone as smart as possible.
Mhm.
And usually the former wins out. So the camp that says, hey, let's try to combine search and AI. And I think if you look at, the analogy, I think, is very apt to where we are today, where a lot of problems around, there's a lot of folks that just sort of try to throw large language models at everything. They'll say, like, hey, let's try to make these context windows as large as possible. To your point as well, how it's sort of like a natural language query. Let's try to make these context windows as large as possible. Let's throw as much information in there as we can, and let the large language model try to pull out all the relevant information for us. That tends to work not as well as if you add a retrieval step. There's many reasons for that, right? I think there's all this lost in the middle stuff, needle in the haystack, et cetera, et cetera. But the core, I think the core point that I want to make here is that search is really, really critical to AI and a lot of modern AI applications.
Yeah, super cool. I've actually begun to think of information retrieval as being more in a spectrum because anything you put in the context window is actually just information retrieval, right? Like
Yeah,
even the prompt,
absolutely.
like a static prompt comes from my head. It's information retrieval from my head into the context window, right? And then there's things that are a little bit more dynamic. At runtime, you might pull it from a database.
Yep.
But at the end of the day, like assembling the information and putting it into the context, that is information retrieval in some respect. Which is like super interesting if you think about it. It's actually just how dynamic the information is allowed to be before it's put in. I'm I'm really curious from your end, digging through all these different buzzwords, what are fundamentals of search? When people, I'm sure in 2026 there'll be a buzzword for search, right? But at the end of the day, like what are things that you think may not change about search? Walk us through maybe like thinking about precision, recall. What are things that people should really think about when they think about search for AI?
Right.
And also just information retrieval overall. Like it's a decades old field, right? So what are, some of the features to understand?
Yeah. Yeah. No, absolutely. I think the long, way the way where in the way early days of information retrieval, I think folks primarily, they used mat sort of keyword matching, I would say. So it was primarily based around lexical search. So it was like BM25, TF-IDF, and a lot of similar techniques around there. But today, it tends to be a little bit more broad. So there's a lot of graph-based retrieval methods. Obviously, there's embedding-based retrieval as well, which is very, very popular to use today. At its core, though, I would say information retrieval is about, you have a query, or you have let's say, a search, and you want to design a system. The system we can just assume is a black box right now. But you want to design a system that pulls out the most relevant information based on your application. So the way that I like to typically define it is you have a query and then you have some sort of function. This function could be a very complex distributed system and it wants to you need to have it pull out a certain set of documents or a certain set of information. Information is typically, typically that it lies in a database somewhere, or it's in a search system somewhere, or it's an S3, something like that, right? And I think if you sort of apply, if you sort of say, hey, this is the input is just a query, and the output is a set of documents, or it's a set of it's a set of information that I want to be able to extract. I think we just look at it from this lens. Obviously, it simplifies the problem a lot, but I think it also keeps, I think it also folks grounded in saying that this is really what we are trying to do. This is all that we're trying to accomplish. Now, there is a lot of nuance here. People were talking. If we go back a year or two, RAG was all the rage. RAG, I would say, is a little bit different from recommendation, even though both of these, in my opinion, are sort of forms of information retrieval.
Mhm.
Recommendation, the query patterns are a little bit different. In recommender systems, you want to get, you want really, really low latency and potentially really high throughput. In RAG, you generally don't care as much about latency because there's a generative step after it.
Interesting.
So the usage patterns are a little bit different. And also with RAG, I also want to add that usually it's like a very multi-tenanted system. So you in a lot of RAG systems, you might not necessarily be searching over, let's say 1 billion documents and finding the most relevant information out of 1 billion documents to give your large language model. So yeah, so I think if you sort of break down, if you say fundamentally all we're trying to do is search and we take the results of that search, if we talk about AI today or a lot of these AI applications being built, we take the results of that search, this black box, right? And we feed that to the large language model in some way and have it be able to generate some insights based off of that. I think that's really all that it is. There's a lot of complexity here. Everyone's saying like, hey, now we're building agents. We have to build agent memory. There's like long-term memory, short-term memory. There's like procedural memory, whatever, right? Like, I think that's fine and all, but at the end of the day, again, distill it down, like you distill the problem down. It's a black box. In that black box, you are just trying to find the most relevant information to give to your large language model. That's it.
Yeah, gotcha. How do people usually evaluate this? Like, how do I know if I have good search or bad search?
Yeah. So this is actually where I see a lot of folks stumble a little bit. Is oftentimes it's very, very hard to get this ground truth data that I'm just talking
Yeah,
that I just mentioned, this sort of golden data sets. But it's really important, right? Irrespective, I would say even if you're not necessarily building semantic search, even if you're just building some sort of document-based retrieval system, I think the ability to actually go in there and say, this is exactly how, I have this data set that I know is the right answers. It's like a ground truth. This is how I'm going to evaluate my system. This is how I'm going to say whether a small tweak or changing the embedding model or adding hybrid search or whatever, adding some graph-based traversal techniques, whether that improves the quality of my search. Having that, being able to ground that in the golden data set is super important.
right. Yeah, yeah. I feel like back in ML, right? There's always the ability to ground it in like a ground truth data set, which for class application is easy. It's like 0 or 1 essentially, or one hot encoding. But in the search world where things are a bit fuzzier, it's like really challenging.
Yeah.
But yeah, so I guess now we've kind of established the foundations of how people should think about search. Here's a really interesting question for you. I think about this a lot. Like, how has search changed in the last 5 years? Now that I think one of the primary consumers of information retrieval will now be agents, right? Do you think there's a big difference there between how agents and AI do search and versus how a human, say on Google, does search? And what are some of those differences there? And how does that change the landscape of how we, build these systems?
I love this question and I would like to hear your opinion on this as well.
Yeah, fun.
Here's my take. Here's my hot take, which is I think so. I can only really speak about document-based retrieval, search, semantic search, and from this perspective. But I think if you it, if I'm traditionally if I'm trying to search for something on Google, I will sort of distill down my query or I will distill down my search prompt into a set of keywords. So for example, when I search for something on Google, I don't ask a question. I don't give it a prompt. I will say, I'll search for maybe like black chair. or I will search for, I'll search for like San Francisco, California. I'm not going to I'm not going to say what are some of the black shares on the market that I can buy today, or I'm also not gonna search for give me the top 10 things to do in San Francisco on a weekend or something like that, right? I'm not gonna search for that. I'm just gonna like sort of pull out very specific keywords and do and give that to the search engine. So in a way, what traditional search engines are doing is they're sort of we have been for a long time, I think we have catered to search engines, if that makes sense. We've
Right.
catered to Google, we've catered to BM25 and TF-IDF, quite frankly.
Right. Yeah.
I think that's going to change you already see that changing very drastically. It's why RAG became super popular. It's why people are talking about agent memory all the time today. And I think that's going to you're seeing like a very, very sudden shift where instead of just typing in some keywords in the search engine, we're giving it prompts, right? We're putting down our thoughts, and then we're relying on this is where embedding based techniques, this is where semantic search techniques really shine, is when you give it a term, when you give it, let's say, a complete sentence, or when you give it a question, or when you give it a prompt that's not just a set of keywords that we have distilled for the computer. So anyway, there's a long-winded answer. Would love to hear your take on it as well.
Yeah. Yeah.
But
Yeah.
uh,
That's super interesting. I feel like if I were to distill that, right, it's almost as if in the past we've really catered towards keyword search to retrieve specific documents that people then care about. Versus now, we're really thinking more in terms of like, do the retrieval and the synthesis of the specific question that I have, right? Which then ends up being like a step one and step two. But then because there's like the semantic meaning in that step two, we almost need the semantic meaning to then carry on to step one. It's like
exactly.
super interesting.
Yeah.
Yeah.
Yeah, exactly. I think there are a lot of and a lot of the existing data sets out there for information retrieval. The reason why you see a lot of traditional methods perform so well on them is because when you go and mine these data sets are mined in a way that these data sets are mined under the assumption that humans type in keywords, or that they type in, they'll again, I'm using this term a lot, but they'll distill down exactly what they're thinking into maybe 5 or 6 words max, right? Or a short phrase. And that's just not how we're going to interact with computers now that we have large language models.
Yeah, 100%. Yeah, I guess my take on it too is I've been talking to a lot of people about this topic, and it ultimately boils down to humans are lazy, but AI
Yeah,
agents are not, you know? So
exactly.
like the kind of what you said, right? We tend to think very simplistic, like, hey, like high level, here's what I want, like 5 words. But an agent is kind of more than happy if you pay the GPU money to just generate a bunch more tokens.
Exactly.
And so, you know how in Google you have that search language, but like people don't really use it that much. But for an agent, if you give it like a more complicated kind of query language, it will happily use it, right? Or for an agent, if you gave it 100 documents to look through, it will happily do it. Versus a
Exactly.
human, you go like, I'm feeling lucky and hit the top one.
Exactly. Right. Like, how many people actually use the and or terms inside of
Yeah.
Google? Very, very few people actually do that.
Yeah. Yeah, that's super interesting. And to me, I just always wonder, I think you've already pointed this out, whether this opens up the world to like a much wider set of like new search systems that are catered for this, right? And you've touched a little bit on like embeddings. I'd love to hear from your point of view whether you think embeddings are kind of this new wave of search systems, or have they been maybe a little bit overrated? I had some folks on the podcast say actually they feel like there's been an overcorrection against embeddings. Uh, Now people are like underestimating how much they can do. I'd love to hear your take.
Okay, so I think embeddings are overrated and underrated at the same time. And I know that's a very weird take, but let me explain. I would say they're overrated because what a lot of people will do is they will say, "Oh, hey, I watched this video, I watched this talk about agent memory is just using embeddings, or I watched this talk about RAG and it's just using embeddings." Uh, n- that might not be using embeddings and embeddings alone might not be exactly what makes or breaks exactly the most optimal for your use case. A lot of it depends, right? I think if you look at a product like Glean, I think it's very obvious for Glean that having something, having embedding just be a small part of the search is very important. There's also things that they have to do, like, there's also sort of people relations. There's also like a lot of graph traversal that they have to do for sure. And I think if you told Gleans, I had said like, hey, tomorrow just move to something that's purely embeddings, I think it would be a much, much worse experience than what it is today. And, again, this is coming from someone who like joined a company that builds embedding models, right? Like, so yeah. So I think embeddings are certainly, from that perspective, they are overrated. I would say where they are underrated is I see a lot of people out there that just say, just use BM25, just use TF-IDF, or use hybrid search, right? This is very, very common. And again, it goes back to my point a little bit earlier, which is we really should not be thinking that way, because a lot of the existing data sets out there that have been mined for information retrieval, and a lot of the traditional ways of us interacting with computers are with keywords, and that's just not how AI agents interact with each other. That's not how we interact with large language models. If you type something in ChatGPT, it's likely that you type a question, or you type there's some sort of longer form prompt. And the only way, if you want to be able to search for the right information, the best way to do that is with embedding based search. Right. It is not with some combination of keyword search and embedding search, and you're adding all this extra latency and increasing the complexity of your system. I do think embedding based search is there for that. So again, I will say, like, for a lot of these agent memory, and for a lot of these RAG use cases, embedding based search is the way to go. There's all this hybrid search nonsense, all this keyword search. I know it might be a hot take, but that's not the way that things are going to be done in the future. And then also, for to take it another step up, sometimes you're building an application that requires a lot more data, that requires a lot more knowledge than just what you have baked into the embeddings. I use Green as an example there. And in that case, you don't want to just use embeddings, right? You want to maybe add some graph traversal in there. Maybe you want to do some um, filters, or maybe you want to add in some post filters, and that's very, very important, I think, to consider as well. Maybe you want to add a re-ranking step in there as well. So that's my take. That's why I think it's that's why I think it's both overrated and underrated at the same time. But we'll see how things go. I'm not an oracle.
No, we love hot takes on this podcast. Like one of the questions I usually ask is, yeah, what do you think will happen in 2026? And so people are like, yeah, like, don't hold me accountable for this, but here's what I think. So I love this take on your end, where it seems like you're bullish on embeddings for a certain class of use cases.
Absolutely. Yeah.
Yeah, and just really that semantic meaning, I guess, that like keyword
Yep.
search just never really
Yep.
captures, right?
Yeah. Yeah.
Yeah.
Yeah, absolutely. Absolutely.
Yeah, I'm super interested too. You mentioned Glean and like a bunch of other systems. I think a lot about this, like how much pre-processing of the data is required. Traditionally we think of search as like, hey, yes, do search, retrieve the raw form of the data, right? Like the
Mm,
the raw, say, like chunk or the raw document, and then you feed that into the AI systems. More and more, I'm seeing more of use cases like you do a little bit of captioning, or you do like summarization, contextual summarization, right? Pretend to be a financial analyst and like do something so that then later on it's useful for an agent. How much do you think about that, and do you think that's a trend that will continue to grow? And I guess like data processing up front, right, in order to power search. What does that look like in the future?
that's a great question. That's a great question. I think data processing for search is extremely, extremely important. I don't have a ton of visibility into it. I think because throughout my career, I've really been focused on sort of like this embedding based search vertical. But even if for even as you're generating, let's say you have text embeddings, even for folks who are, there's still many, many steps to get to the text that you then use to embed and store inside of a vector database, right? There's many, many pre-processing steps before that. Sometimes people will do something maybe a little bit more high touch, like take a video, give that to a large language model, ask it to summarize the contents of that video, right? Or figure out what's going on in a particular scene. In other instances, so in that case, there's a large language model that's a part of that data pre-processing pipeline. In other cases, sometimes you just want to do some plumbing, right? So Fivetran built, like a multi-billion dollar business based off of this, and this is for structured
Right.
data,
Right.
right? And there's so much unstructured data out there. So who knows? Maybe that's like a multi-trillion dollar business. But
Yeah. Well,
In many
that's what
cases,
we're hoping with Daft, unstructured ETL. You gotta move the data, you gotta transform the data. But yeah, you're absolutely right.
I think there's a lot of value there, right? This is the because sometimes you have all this data stored in many different places, and you have to get it into maybe you're trying to figure out how to get it into one, how to make all that data searchable. You have to get all of it into one vector store, or maybe you're using multiple vector stores for different users. Again, it depends a lot on your application, depends on where a lot of that data lives, and there's quite frankly, I think there's a lot that if you realize that there's many different sources of data that you can that you can figure out how to turn into text or turn into some visuals, and give that to an LM, give that to an AI and have that AI generate insights based off of it. I think that is where you're going to unlock a lot of those, a lot of the value, out of a lot of the value out of your existing corpus. So yeah, I mean that's my take. I think it's super important. Yeah, sometimes it's about transformation. Sometimes, as I mentioned, it's about plumbing. Other times, it's a combination of many of these and or both of these in different steps. I think either way, like if the more data that you have and the more ways of being able to capture that data, give it to AI, I think it's going to unlock a lot more use cases, for
Yeah.
companies and
Yeah,
organizations.
super cool. I also wonder on your end how much you're seeing kind of like very domain specific and very application specific types of search, right? I think, I was talking to someone the other day and we were just talking about how, say, you might want to build search on top of Slack, right? It's like simple. If you think about it, it's simple. Let me just find the right messages. But, there's other signals. Like maybe you want messages with a lot of thumbs up emojis, right? Or if you have like thumbs down emojis, you might downrank that. There's all these
Yeah.
other signals out there that don't exist for, say, a PDF document or
Yep.
archive. And like how are people today maybe thinking about that? And I'm very curious on your experience. Do you see a lot of maybe fine tuning of embedding models for
Mm.
specific kind of use cases when people are really trying to do search for a very specific kind of domain or application? And what do you think about these this like custom work around getting domain specific search to work?
Yeah, I think domain specificity. So when it comes specifically to embeddings, I think if there is, I think sort of fine-tuned embeddings, I think there's certainly a lot of value in that. To fine-tune it for a very specific application or for a very specific user or a subset of vertical of users. I think the other point to make is that for different different applications have many different sort of ways that you can combine a lot of these pieces of data together. So I was talking just anecdotally as well. I was also talking to a company and they're interested in they have a corpus of videos and they're interested in making that corpus of video searchable. There is a lot of different the problem is that corpus is not homogeneous, right? That corpus contains many different clips of different things. So without diving too much into the use case or without diving too much into details, you can think of like some of the clips are, could potentially be, let's say, movie scenes. Others could be, clips from, let's say like, the news at 7 o'clock, or, others could be some late night shows. And all of these have their own separate signals that you would then want to incorporate into that search. So for movie scenes, for example, you want to be able to, there's sort of ratings, right? So if you on Rotten Tomatoes or even on the platform itself, there's some subset of users that will give it, as you mentioned, right, thumbs up, thumbs down.
Mhm.
For things like news clips, right? There's the specific time when that takes place. There is the anchor. There is whether or not there's they talked about weather inside of that inside of the 7 o'clock news. Right. And there's many other signals that you want to incorporate into that search. So going beyond just fine tuning, I think you have to. And I made this point a little bit earlier too. You have to fine tune your application. There's still engineering and there's still plumbing and there's still work to be done beyond just saying, let's take our unstructured data, let's embed it, and let's figure it out from there. You still have to build the application around that. I think embeddings and search, information retrieval, that forms a foundation. But it's just a tool in your toolbox that you have to use to build a broader application on top of it. And when I think I talk to customers pretty frequently, and the most successful customers I've seen understand this point. They understand that embeddings and vector search, et cetera, this is just These are just tools in the toolbox. They realize that there's still a lot of application code to be done to just get that data where you want it in a form that you want it. So I think fine tuning embeddings, I think that there's definitely value there. The phrase that I'll use here, I'm really making this up, is you also have to fine tune your application as well.
All right, put that on the billboard. Coined first here by Frank. Fine tune your application.
Yeah, yeah. So yeah, that's my 2 cents there. And I think if you are if you're a listener and you're thinking about building, some AI application, just remember that that is arguably the most important point. So it's saying, hey, let's not just look at a notebook and look at a notebook that leverages, some embeddings and a vector DB and, put that in production. Right? It's never going to work.
Yeah. Do you have an estimation of how far does that get you though? Does that get you like 80% of the way there if you just do
Mm,
naive or chunk and then embed and write and like you get like 80% of the way there? Or is this more like a 50% and there is still a bunch of work you gotta do to actually make this a
yeah.
compelling kind of application in
Yeah,
most use cases?
yeah. I would say it's 50%. And in some cases, possibly even less. If you have a
Really?
lot of disparate data sources, I think it's definitely it's probably less than 50%. So 50% is actually maybe an upside case in this instance. If you just naively take a set of documents, embed it, you don't even do things like attach some metadata to it, or you don't attach any scalar fields to it, I think you're not gonna have a great experience. There's always, always, always scalar fields that you can attach. So for example, like the user ID, to go back to user ID, for example, is an obvious one. To go back to the example that I was giving around videos, the date that video was uploaded, searching over a corpus of videos, you don't want to search for something that was uploaded in maybe or some content that was created in 1980 or 1990, or maybe you want to somehow downweight that based off of the search query or based off of the search term. So again, putting all of that together, understanding what your users' needs are, and engineering something based off of that, that leverages, let's say, Daft or leverages Eventual and leverages a lot of these tools. That's going to be the most important thing.
Yeah, super interesting. So I guess I'm hearing a couple of things. One is if you have the more homogeneous your data set or your application is, the easier it will be to build better search, right? Because you don't have to account for different types of data. And the second part is like putting in the effort to add, I guess, call them metadata fields, attribute fields to your
Sure.
documents, and not just purely relying on the semantic layer for just like a really wide search will help a ton.
Completely agree. Completely agree. And again, once again, this is coming from someone who, like does like vectors is like really into vector search and works at a company that is building embedding models, right? So yeah. I totally agree with that point.
Yeah, super cool. Okay, I guess like let's go to the last thing for this podcast.
I love it.
2026 hot takes.
Okay.
Let's go. Where do you think AI is going to go, and specifically search within AI, which I think in my head at least that is kind of one of the big unsolved problems today. Search
Mhm.
within AI. Today we have, I think we've moved past RAG. Now we're in this weird like agentic search world
Yep.
now. What does 2026 look like? What are some of the bubblings of like new things you're seeing here?
So a lot of this ends up time. So RAG was really just the first step. So RAG was just saying I have some documents. Let me find the documents that are most relevant to my query or to my prompt, and let me give that to a large language model. I think in 2026 and 2027 moving forward, you're going to start to see uh, all the things, these buzzwords I was talking about earlier: context engineering, agent memory, and it's all really going to come together. I think you're going to see, similar to the analogy that I made earlier, which is if you look at Stockfish, they have a much more lightweight neural network, and they also rely on search. And the neural network in many ways drives the search. So if there's a particular node where the evaluation is very very bad, then that is probably going to get pruned. I think you're going to see something very similar here, where you're going to see, first of all, the language models are going to get smaller. There's going to be less knowledge that's built into the language models. I don't know how. I think much smarter people than myself will figure that out. The language models themselves are going to be smaller. So instead of these, 1 trillion or 10 trillion parameter language models, you might, you're going to see them go down to maybe 100 billion, maybe even 10 billion parameters, but they're going to be really, really good at, they're going to have what I like to sort of call like a core set of knowledge that you need to be able to do things. So to give you an example, a lot of these coding agents, they've been trained on tons and tons of Python. They know, and tons and tons of Python libraries as well. They know how to use NumPy, SciPy out of the box without looking at the documentation. Instead, what you're going to see moving forward is the language models are going to be much smaller. They know how to do lookups. They know how to look up documentation really, really well, but they don't necessarily know how to use NumPy out of the box. They don't know how to use NumPy without looking up that documentation.
Mhm.
I think that's where we're going to go moving forward. So there's going to be much, much more of a focus on agentic retrieval. The language models are going to get smaller. Once you get there, you focus less on the knowledge that's baked into the model and more on saying, hey, we're going to ground the large language model in stuff that we know is actually true to be a good source of truth. I think that's where we're going to see fewer hallucinations. You're actually going to see more large language model based applications deployed across enterprises. And it's also going to be useful. It's also just going to be more useful from on personal level as well. If you use ChatGPT, obviously I have like memories and all this kind of stuff now too. So that's my prediction, especially in and around search and retrieval. Again, I'm not an oracle, so it might not become
All
true.
right.
Language
There's a
models,
hot take.
might continue to be 1 trillion, 10 trillion parameters, right?
Yeah.
They might not get smaller, but I think honestly, I also think all this spending on data centers to run, like these massive models is probably not scalable in the long run.
Yeah, super cool. So I guess like dumb models with a good set of core capabilities and access to
Yes.
like really good search systems is
Yep.
kind of the hot take
Yep.
here. All right, we'll check back in at the end of 2026 and see where that lands. Yeah. Thank you so much for being here with me today. It's Thanksgiving, by the way, for those who see this video later, right? So thanks for spending your Thanksgiving day with me. And yeah, super, super interesting to learn more about from you about embeddings and search and AI. And thanks again, Frank.
Yeah. Thanks for having me on, Jade. See you around.
Thanks for listening to this episode of Zero Shot Espresso. If you liked the episode, share it with another engineer who spends way too much time thinking about data systems in the age of AI. See you next time.